Alright, so we're going to learn about complex fractions. And so complex fractions kind of remind me of birthday cakes. And so here we have a birthday cake, or wedding cake. So this kind of looks like that. And so I just call these wedding cake problems. So complex fractions are really no different than just the dividing that we've been doing, except with some extra steps in there. So with complex fractions, the first thing you're going to do is get a common denominator in the top, and then get a common denominator in the bottom, and then flip the bottom fraction and multiply. So let's look at this first one. So I want to get a common denominator in the top first. So it's almost like I'm kind of just going to think about just that top piece and treat it as just one problem right now. So in order to get a common denominator in the top, I'm going to multiply the first fraction by x plus 3, and use an x plus 3 in the bottom, and the second fraction by an x minus 5. So across the top, I'm going to have to FOIL that out, and I'm going to go ahead and do that in my head. X times x is just x squared, and then x times 3 is 3x, 1 times x is 1x, so I'm just going to say plus 4x, and then 1 times 3 is 3, so plus 3. And then I'm going to distribute the 2 to the x minus 5, so this is just going to be plus 2x minus 10. All over my common denominator, x plus 3, x minus 5. So I've done the first half, or the top part of that. Now I'm going to do the exact same thing with the bottom of this fraction. So this is going to end up giving me an x minus 5. Here it needs an x minus 5. This needs an x minus 3, not a minus but a plus, and an x plus 3. And so then I'm just going to distribute across the top of the bottom fraction. And so when I do that, that's going to give me x times x is x squared, and x times negative 5 is going to be a minus 5x. Alright, then second fraction, x times x is going to give me a plus x squared, and then x times 3 is just going to be a plus 3x. And so then that's all over x plus 3, x minus 5. Now, I want to show you why we're going to be able to cancel stuff at this step. So right here, this line just means divide. So it's really the same thing as when we had a problem that was something like this. And so that divide just means I'm going to take this fraction and we flipped it. So I'm going to do the same thing with the bottom fraction. It comes after the divide, and so I'm just going to take this and flip it. And so when I do that, the x plus 3's and x minus 5's are going to cancel out. So if some of you can see it there, you can go ahead and cancel x plus 3, x minus 5. I'm just going to show you that step on this one. But if we combine like terms in the top, that's going to give me x squared. I'm going to go ahead and combine that. That's going to give me plus 6x. 3 minus 10 is just a negative 7. And so that's over my x plus 3, x minus 5. Remember, I'm just showing you the step this time. Now, I'm going to go ahead and flip this bottom fraction. And when I do, the sign changes to multiply right there. And so the bottom, this x plus 3 over, or x plus 3 and x minus 5, since I flip it, are going to go here. And so when I combine like terms, x squareds are going to be 2x squared. Negative 5x plus 3 is just a negative 2x. And see, this is why my x plus 3's and x minus 5's can cancel, because when I flip and change the sign to multiply, it'll cancel. Okay, so you could go ahead and cancel them there. Either way is fine with me. So I'm going to go ahead and factor the top of that first fraction. So that's going to factor into x plus 7 and x minus 1. And I can take out a GCF, not of negative 2. Whoopsie. Okay, but I can take out a GCF of 2x. And so when I take out a GCF of 2x, that'll be x minus 1. And so then my x minus 1's will cancel, and my final answer will be x plus 7 over 2x. Alright, number 2. So this one, if you have one that doesn't have a denominator, I'm going to work with, again, just the first top of that fraction right here. This is kind of like a 1 that's under there. Okay, so I'm going to stick a 1 under there just to hold that place. So the first fraction needs an x plus 4. So I'm going to make this x plus 4, x plus 4. And so let's go ahead and distribute or FOIL across the top. So x times x is going to be x squared. outside terms and inside terms both give me 4x, so when I combine them I get 8x. And then 4 times 4 is plus 16, and then I've got a minus 1 on the end. Okay, that didn't need anything because it's already got that x plus 4, so I'm going to stick that over x plus 4. Now, bottom part, I'm going to put that over 1, so it's going to need an x minus 3 and an x minus 3. So I'm going to go ahead and FOIL. So that's going to give me x squared. And then outsides give me negative 3. Insides give me positive 11. So 11 minus 3 is going to end up giving me plus 8x. Alright, and then 11 times negative 3 is just minus 33. And I've got the plus 48 on the end over x minus 3. Now, they're not going to cancel on this one because those are not the same. So when I flip and multiply, it's not going to cancel. So I'm going to go ahead, and because this one's on the bottom, I'm going to flip the bottom fraction. And so when I do, I'm going to go ahead and combine like terms. I'll have x squared plus 8x, and then that'll be plus 15 over x plus 4 times the x minus 3 goes on top now. And when I combine like terms, x squared plus x, and then negative 33 plus 48 is going to end up giving me a positive 15. And so then I don't even really have to try to backwards FOIL these two things because they're already the same and they'll cancel out. And so my final answer is just going to be x minus 3 over x plus 4. Yay! Alright, third one. How many of these we got? Oh, last one. Okay, so this one is a little bit tricky just because it looks different. You don't have as many layers of the cake. So what I'm going to do, this x minus 7 in the very top doesn't have a denominator. And so I like to see a denominator, but you don't have to do this. But I like to see a denominator, so what I do is I just stick that over 1 because it's the same difference. And so then the second fraction is where I'm going to go ahead and get a common denominator. And so I need an x here, I need a 7 there. So when I multiply this, x times x is going to give me x squared minus 7 times 7 is 49 over my common denominator, which is 7x. Now, bottom fraction, I'm going to take this and flip it. So this is going to give me x minus 7 over 1 times. This is going to end up giving me on top a 7x over, that's a dots, x squared minus 49 is dots. So this is x plus 7, x minus 7. And so then my x minus 7s will cancel out. And so 7x over x plus 7 is my final answer, because that 1 times x plus 7, that's just going to stay to x plus 7. Alrighty. I think that's it.